Thank you all for joining this short webinar on eOceans, a platform for collaborative, inclusive, and real-time ocean science. I'm Christine Wardpage, a marine scientist and creator of eOceans. I've worked for government, NOAA and DFO, academia, industry, and NGOs. I specialize in endangered and rare species like sharks and rays and the impacts of pollution and evaluating policies, like marine protected areas, on the socio-ecological dimensions of the ocean. And I've worked on marine disease, carbon sequestration, indicator and invading species, isotope chemistry, biodiversity, carrying capacity, economics, and more. Over the last 20 years, I moved from being a field biologist to running one of the largest participatory or citizen science projects through eOceans. Many years ago, when I met the late Ransom Myers, I had an important realization that I didn't just have a fun job that every kid wants to be. No, when I met Ram, I realized how important a marine scientist's job is. Everything we know about the ocean and its influence on society depends on the important discoveries made by marine scientists. But then I realized just how manual, siloed, and slow we move. We're still writing it all down and analyzing for one question at a time, so our discoveries lag years to decades behind business, society, and ocean change. I took to crowdsourcing data mostly through online questionnaires and surveys of ocean explorers around the world. But others now use phone hotlines, emails, or species-specific mobile apps. For example, people love manta rays. Tourists spend more than $140 million a year in just 10 communities to see them. So alarms rang when they started to disappear, and that's when I was solicited to help. By crowdsourcing observations from ocean explorers around the world, we revealed that although only 2 countries reported catching manta rays, they were being caught and sold in markets around the world. And this discrepancy was enough to help them get on the endangered species list, or CITES Appendix 2. But even this was still manual, more than 500,000 records in 90 regions of the world. And given ethics around research, we can really only use these data for the purpose that we gathered it for. It can't be reused with any precision, which is such a waste of everyone's time. One study found in 2015 found that although $2.5 billion of in-kind data are provided by the public or citizen scientists, only 12% are used. Most of the people I've talked to collect citizen science data with the hope that someone like me will use it. I've even seen it on websites that said they were collecting data for me, but I couldn't use it because of a lack of standardization. And frankly, it covered too small of an area, too few species or issues, or a time period to be worth trying to standardize. And finally, it's a black box from the contributor's perspective. It's very hard to share the science that people contribute to, even if it is an open access journal. So for example, look at this paper I have in my own queue. This is a very important study that was initiated by the tourism industry in Fiji, who noticed shark populations changing or declining in many areas. But they didn't have the data to support it or to make actions. So they reached out to me to help with the data collection and analysis and proceeded to sample 592 sites 30,000 times and made 146,000 shark observations. The data cleaning took many, many months over many, many years and a lot of back and forth, then the analysis and report writing, and we're still trying to finish it up before it can serve its purpose of management or conservation decisions. It's very, very slow. And this isn't rare. Look at some of these other papers, even with Jessica and David at DFO. We're studying the effectiveness of super important time area closures that would protect cod, for example, with decades of data. And all these papers look at a window of time that was far in the past or even just years ago. And this is not just me. If you look around at many papers, they're published years after the time period that was sampled. So this paper, for example, this report was sent to me. It's a hugely valuable report on a very important species in our region. And I can only imagine how much time and effort went into creating it. But it was published in 2021 and covers the years 2010 to 2015, which is very similar to my Fiji shark paper. It's really hard to bring disparate data sets together to clean quality control, analyze, visualize, and write a report on any topic really, and especially the ones that are so socially important. So I'm going to ask you to do a little exercise with me to imagine if we knew how salmon was doing today. Imagine if you could have all government scientists doing their work on salmon and digitizing and analyzing their data in real time. And at the same time, all the other community groups, tourism operators, the province, and recreational fishers doing theirs all separately could also combine their data into a larger sort of meta-analysis in real time, including the presence and absence of salmon, cohabiting species, water quality, pollution events, and many more things within a multidimensional, multivariate modeling framework. And you could be doing this with other groups across the range of the species. Oh, and you could get text notifications when outliers are observed, such as animals arriving early or late or not at all compared to previous years. And finally, you could get this report that your team of scientists are continuously following results and updating interpretations on demand. And of course, it's not just salmon or sharks in Fiji. It's eels, lobster, shark, fish, crabs, and other invertebrates and whales. And all these interact with invasive species, pollution, shipping, fishing, mining, construction, and more. And those layers interact with the layers of interventions like marine protected areas or reserves, fisheries management, education and outreach, conservation, and so on. And it's not just about the science, but also the impact on society. DFO and many other governments have many important files that they manage and the objectives that the public cares about. We desperately needed a tool that considered all this noise and simplified it, generating insights at the spatial and temporal scale needed, and disseminates it back to the public in real time. That is why I created eOceans. Our goal is to get all ocean stakeholders and rights holders and decision makers in one place to track the ocean and make informed and collaborative decisions and actions on timescales that keep pace with business, society, and ocean change. eOceans automates all the tedious and time-consuming aspects of ocean science for speed, efficiency, impact, co-generation, and action. We have a variety of tools to digitize data at sea in real time for quality control, standardization, storage, analysis, visualization, report generation, dissemination, co-interpretation, urgent matter notifications, and so on. The ultimate goal being to answer this question: how is your MPA, ocean, coastline, species, blue economy, blue carbon, etc. doing today? So, how does it work? Here, I'll focus on two different points of view. First, on the scientists and decision makers. Then I will give an insight onto the stakeholders' point of view, or the contributors. First, here's your dashboard. I'll walk you through the different parts. The first is location. Everything inside of eOceans is based on a shapefile. A shapefile delineates the area of interest. All the data that's recorded inside of your area of interest goes to your team that's relevant. So if you're interested in whales and somebody reports a whale, including zeros, you get that data. And here I've shown a polygon, so the inner side could be your study area, and you might, for example, with marine protected areas, want to study a buffer area around your study area to understand, for example, fishing the line. So you can also add that. The next tab over is observations. That's where you'll see all the observations from the people who are reporting. Overview, that's just a summary of what your team is doing. Then there's management. So management, that's in the case of marine protected areas or anything like that, where you want to say what activities are restricted or allowed in an area. So it's kind of communicating those allowances. Then there's the description, that's more in-depth description of your project. Results, that's where you'd find those inside there. That's where you'll find your real-time results about your team. Discussion. This is for the admins. You can kind of think that this is the discussion in a paper. So as the admins or the team leads are reviewing the results, they can be writing the discussion and discussing what they're finding. Users, that's where you manage your users, who's a member of your team and who's part of the admin team. Comments, that's where you can solicit comments from the public or from members of your team. So in the case of my Fiji paper, I can solicit, co-interpretation of the results. Metrics, those are results around your team. So it's different than results, but it says who is involved in your team. So for example, if you're tracking the blue economy and you want to know how many people are coming from where to use your coastal ecosystems, then it tells you essentially like how much love your coastal area is getting. Then you've got reports, and reports is where you click on that to download your PDF report or data downloads. And then the next thing, after you've created your team, you decide what data goes into your team. What data do you want to feed your team? So far, we've integrated with OBIS and NOAA's ERDAP, which means based on your area and species of interest, we'll crawl these data sets and recommend any matches. And then you can decide if you want to add any of those data sets to your team. Then the primary data feed is via the eOceans mobile app for at-sea real-time data collection. We have 500,000 species, hundreds of activities and human observations, and it includes effort, which importantly enables the collection of zeros. So you download the app, you join the teams that you want to join, and then you go out logging observations. So like I said, it could be of a species, it could be of an invasive species, it could be of pollution events, and so on. And I should note here that we support FAIR data principles. That's findable, accessible, interoperable, and reproducible. But we don't make the data open or freely available. We see eOceans as a platform to facilitate open science, but the user owns their data and decides who can access it and for what purpose. This is essential for building trust, enabling collaboration amongst stakeholders and rights holders, including fishers, traditional, and local knowledge holders, as it enables data democracy, data sovereignty, and the right to be informed and make decisions about what you are involved in. It also, I will note, it also provides protection for endangered species or targeted species and special places. So next, we have the notification system. This can be in-app or text or an email notification. This enables you as the admin to not only collect data, but to be notified of things that you want to be alerted to, such as outliers, species that are in risky places like a whale in a shipping channel, or a whale nearby ghost fishing gear, or a bomb being washed up on shore, illegal fishing, and much more. Whatever you as the team lead determines to be worthy. Then there are the analyses. These can include summaries, eOceans standards, which are advanced multivariate analysis that control for things like effort, site, season, and then custom analytics. These can cover social, biological, and anthropogenic dimensions of the ocean, and you can slice and dice the data however you want. And we're building a series of trackers and scores. Currently, we have the MPA Health Tracker and MPA Health Score that work at the MPA, MPA Network, and MPA Network of Network scales. And stay tuned for future trackers that include sharks, rays, and the blue economy. Then there's the Cointerpretation channel, where team admins and members can discuss the results with the members of their team. This is important for building trust and gathering multiple perspectives on trends. Then generate PDF team reports. Currently, they are eOceans styled reports, but you can let us know if you want something that matches your organization. And finally, there are data downloads. These are standardized with metadata following Darwin Core standards for interoperability and for whatever you need to have them for, like archives. And looking back at my paper that's in the queue, if we had had eOceans app for data collection, QA, QC, processing, and analysis, we would have been able to track species composition by site, month, and year, and been able to see these populations change. You'll see in the bottom left panel that white-tip reef sharks, which are the most commonly sighted shark, are decreasing across all sites in the eastern parts of Fiji and increasing on the western parts of Fiji. And so now we can do this in real time with eOceans. So on the other side of eOceans, an essential side when collaborating with people, communities, businesses, and more, is we want to know, how does eOceans actually work for collaborators? As I mentioned earlier, citizen science is like a black box. It's really hard to communicate findings, especially if published, even affordably behind paywalls. So we can't, it's very challenging. I've found it very challenging to share my papers back to people who are participating. At the same time, these millions of ocean explorers already log their efforts and observations for their own purposes, for captain or dive logs, as activity tracking, and to social media. So they're really donating their time redundantly to contribute to science. And it's super hard for them to keep track of and report to all the different scientists who are interested in collecting their data. For example, in Fiji and in Thailand, while we were running the shark assessments, there were many other researchers also asking for shark observations, which made it frustrating for the people that lived there trying to report their sharks to all the different locations. And here's a local example in Canada of a person that keeps track of all the trash they find on the coast of the Bay of Fundy and shares it to social media, where it can importantly raise awareness, but it doesn't feed back into science or decision making, but it could. And not only does the mobile app allow them to track their activities and observations for their own purpose, we also built a downloadable logbook and impact report where they can see all their data and contributions to science, whether just one project or thousands. Here I'm going to share a short 3-minute video of eOceans from a fisher's point of view, using quotes directly from fishers. Okay, in summary and looking forward, eOceans allows us, scientists, businesses, managers, decision makers, and society to simultaneously track the biological, social, economic, cultural, and anthropogenic dimensions of the ocean, with interventions collaboratively, inclusively, and in real time, and across complex, dynamic, and interconnected spaces. This not only helps with all that I've mentioned thus far, but also supports larger international objectives such as Sustainable Development Goals and the United Nations Decade of Ocean Science for Sustainable Development. Finally, I have one ask. Given the need for real-time insights for informed and dynamic decision-making across the board, and that every researcher I've ever met or worked with already has more work than they can fit into their week, where should we start? How would you use eOceans today? What are the 3 most urgent issues that we need to track and understand today? Please let us know in the comments below or send us an email. There is really no time for slow science, and eOceans is the platform that can help you keep up with change. For the ocean, for us.